everyone, and Dr. Azlin. We are group 3, and we'll be talking about hydrogen fuel vehicles for our assignment 2. I hope you enjoy our presentation. Our team consists of 8 members, which are me, Sui, Fatin, Atika, Daniel, Kelly, Bing Shun, Ahmad Atkim, and Bianca. The transportation sector is one of the major contributors to greenhouse gas emissions due to the widespread use of gasoline and diesel vehicles. These vehicles release pollutants such as carbon dioxide, nitrogen oxides, particulate matter, and volatile organic compounds, which contribute to climate change, air pollution, and health problems. As fossil fuel resources continue to decline, there is an increasing demand for cleaner and more sustainable transportation technologies. One promising alternative is hydrogen fuel cell vehicles. These vehicles use proton exchange membrane fuel cells to generate electricity, with water as the main byproduct. So, to continue our presentation, we'll talk about how hydrogen fuel technology actually supports the 12 principles of green chemistry. There are 4 main objectives in this presentation. First, we will study the working principles of hydrogen fuel cell vehicles. Second, we will look at how hydrogen is converted into electrical energy using fuel cell technology. Third, we will evaluate both advantages and challenges of hydrogen fuel cell vehicles. And lastly, we will investigate safety improvements and future developments of hydrogen fuel vehicles.
Hi, my name is Atika. So today I will be explaining the problem statement. So the main problem related to transportation today is that the heavy use of petrol vehicles contributes to air pollution, greenhouse gas emissions, and the depletion of fossil fuels. Petrol vehicles releases harmful gases such as carbon dioxide and nitrogen dioxide that negatively affect not only humans but the environment. So, hydrogen fuel cell vehicles, or HFCVs, are introduced as a cleaner and more energy efficient alternative because they only produce water as their byproduct. However, despite these environmental benefits, HCFVs still face several challenges. These include the high cost of hydrogen production, limited refueling of infrastructure, difficulties in hydrogen storage and transportation, and also concerns about hydrogen production methods that still depend on fossil fuels. These issues make it difficult for hydrogen fuel vehicles to be widely adopted.
Principle 1. Prevent waste. Prevent waste is hydrogen fuel vehicle. Prevent waste means avoiding waste before it is produced. Hydrogen fuel vehicle use fuel cell instead of burning petrol or diesel. The fuel cell reaction producing mainly water and electricity. Chemical and physical waste reduction. Chemical waste reduce. Less air pollution, acid rain and respiration problem. Physical waste reduce. Less salt and particulate matter. Less exhaust residues. Less consumption related waste. When hydrogen is produced using renewable energy, if hydrogen comes from fossil fuel, may still be produced. Other issues include high cost refueling infrastructure, hydrogen storage and recycling of fuel cell part. Hydrogen fuel vehicles support the prevent waste principle because they reduce harmful chemical and physical waste, but their benefits depend on clean hydrogen production and proper recycling.
Next, hydrogen fuel cells demonstrate the green chemistry principle of maximizing atom economy. So you might ask, what is atom economy? Atom economy means that the most reactant atoms are converted into useful products instead of waste. In hydrogen fuel cells, hydrogen reacts with oxygen to produce water. Almost all atoms are efficiently utilized, producing electricity, heat, and water with minimal chemical waste. As shown below, hydrogen fuel cells also show that it produces very low pollutant emissions. including no soot and no direct carbon dioxide emissions at the tailpipe. This contributes to cleaner air quality and reduced environmental pollution. In addition, studies on Toyota Mirai showed improved fuel efficiency, lowering fossil fuel use and reduced greenhouse gases emissions compared to conventional gasoline vehicles. Besides, hydrogen fuel cells also support the third principle of green chemistry, which is less hazardous chemical synthesis because they operate without fossil fuel combustion. As shown in the clean energy conversion section, hydrogen fuel cells produces very low levels of carbon monoxides, sulfur oxides, and particulate matter, while also eliminating toxic combustion byproducts such as benzene compounds. In addition, they produce zero tailpipe pollutant emissions. Research from Oregon National Laboratory reported lower fossil energy use and lower greenhouse gas emissions compared to gasoline vehicles. However, there are still limitations to hydrogen technology. It's shown below. The environmental impact depends on how hydrogen is produced. Electrolysis using renewable energy is considered low carbon, while steam methane reforming still produces carbon dioxide emissions. Furthermore, hydrogen technology currently faces challenges such as high cost, high demand, and infrastructure limitations, which would make battery electric vehicles more energy efficient in some cases.
Next, I will explain about Principle 4, which is safer chemical and product. This principle means chemicals and products should be safer for humans and the environment while still performing their function effectively. Hydrogen fuel vehicles are considered safer because they produce water vapor instead of harmful smoke from petrol and diesel vehicles. As shown in simplified equation, 2H2 plus O2 equal to 2H2O. Hydrogen react with oxygen to produce water. This means there are no carbon dioxide emission, no sulfur oxides, and very low particulate matter released into environment. Because of this, hydrogen vehicles help reduce air pollution, respiratory disease, and global warming. They also improve air quality, especially in urban areas. Modern hydrogen vehicles also include safety features such as strong hydrogen storage tanks, leak detection sensors, and automatic shut-off systems. However, hydrogen is highly flammable, so proper storage, handling, and maintenance are important. In conclusion, hydrogen fuel vehicles are safer and cleaner products that support environmental sustainable. So next, I will explain about Principle 5, which is safer solvent and reaction conditions. This principle encourages the use of safer substances and cleaner reaction processes to reduce pollution and dangerous operating conditions. In the Sarawak Hydrogen Bus Project, hydrogen is produced using water electrolysis. The electrolysis equation is 2H2O equal to 2H2 plus O2. This process splits water into hydrogen and oxygen using electricity. Water is used as the main raw material and no toxic organic solvents are needed. Because of this, fewer hazardous chemical wastes are produced compared to fossil fuel refining. Electrolysis also operates under controlled conditions with lower pollution levels and reduced exposure to toxic chemicals. When renewable energy such as hydropower or solar energy is used, the process becomes even more environmentally friendly. For example, the Kuching Hydrogen Project integrates renewable energy for greener hydrogen production. However, there are still some challenges such as high electricity consumption, expensive infrastructure, and the risk of hydrogen leaks because hydrogen gas is highly flammable. So, in conclusions, hydrogen production through water electrolysis supports green chemistry by providing a cleaner and safer production method.
Next, we will discuss Principle 6, which is increasing energy efficiency through hydrogen fuel cell vehicles. Hydrogen fuel cell vehicles are considered energy efficient because they do not rely on combustion like petrol or diesel vehicles. Instead, they use an electrochemical reaction to convert hydrogen directly into electricity. So, as the chemical equation shown there is H2 plus O2 equals to electricity plus H2O. So this means hydrogen reacts with water to produce electricity, while water is the only byproduct. So unlike internal combustion engines or ICE, which lose a large amount of energy as heat, fuel cells operate at lower temperatures and produce less waste heat, and this allows more energy to be used efficiently for powering the vehicle. So in addition, hydrogen fuel cell vehicles also use electric motors, which are much more efficient compared to traditional engines because energy flows efficiently from hydrogen to electricity and into mechanical motion, which helps reduce overall energy loss. So now, as you can see on the slide, this is a comparison between hydrogen fuel cell vehicles and petrol vehicles and battery electric vehicles. So internal combustion vehicles or ICE vehicles can travel between 450 to 800 kilometers and only have an efficiency of around 14 to 17%. They also release pollutants such as CO2 and NO2. So battery electric vehicles are much more efficient because around 27%, but they require a longer charging time for about 30 to 60 minutes and have a shorter driving range of around 200 to 400 kilometers. So hydrogen fuel cell vehicles combine both advantages of both systems. They can travel approximately 400 to 600 kilometers while only taking about 3 to 5 minutes to charge. And their efficiency ranges from around 15 to 27% depending on how the hydrogen is produced. And when green hydrogen is used, the environmental impact is lower because the only byproduct from this is water. And therefore, hydrogen fuel cell vehicles are seen as a promising solution for transportation energy and also reducing pollutions.
Assalamualaikum and good day to everyone. My name is Fatin Nadia and I'm from Environmental Science Management and I am from year 1. And today I'll be presenting about green chemistry principles applied in hydrogen fuel vehicles. Before we begin, green chemistry refers to the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. The main goal of green chemistry is to protect human health and the environment while still supporting technological development. Hydrogen fuel vehicles are one of the best examples of sustainable transportation because they use cleaner energy sources and produce minimal pollution compared to conventional fuel vehicles. For this presentation, we will focus on Principle 7, use renewable feedstocks, and Principle 8, reduce chemical derivatives. Starting with Principle 7, this principle encourages the use of renewable raw materials instead of non-renewable fossil fuels. In hydrogen fuel technology, water or H2O is used as the renewable feedstock instead of petroleum or natural gas. Hydrogen is produced through a process called green electrolysis, where electricity from renewable energy sources such as solar and wind power is used to split water molecules into hydrogen and oxygen. This process is environmentally friendly because it reduces dependence on fossil fuels, lowers greenhouse gas emissions, and creates a nearly zero carbon energy cycle. This represents an important shift from finite resources like petroleum to renewable and sustainable resources like water. Next, let us look at the chemical equation involved in this green electrolysis process. This slide explains the chemical equation involved in hydrogen production through electrolysis. The overall reaction can be shown as: in this reaction, water or H2O acts as a renewable reactant. Renewable electricity from solar or wind energy provides the energy needed for the reaction. The products formed are hydrogen gas and oxygen gas. Hydrogen gas is collected and used as a clean fuel source for hydrogen fuel units, while oxygen gas is safely released as the only byproduct. Scientifically, electrolysis works by breaking the chemical bonds between hydrogen and oxygen atoms in water molecules using electrical energy. One major environmental advantage of this process is that no carbon dioxide or toxic pollutants are produced during the hydrogen generation. Compared to conventional fossil fuel combustion, hydrogen fuel systems reduce air pollution, decrease greenhouse gas emissions, and improve energy sustainability. This makes hydrogen technology an important innovation in achieving cleaner transportation systems and supporting global environmental goals. After understanding hydrogen production, we will now move to Principle 8, which focuses on reducing unnecessary chemical derivatives. Principle 8 of green chemistry is reduce chemical derivatives. This principle emphasizes minimizing unnecessary chemical modifications, extra reagents, and additional processing steps because this process usually generate more waste and consume more energy. In hydrogen fuel vehicles, hydrogen is directly converted into electricity through a fuel cell system without needing complicated intermediate chemical reaction. Inside the fuel cells, hydrogen undergoes oxidation at the anode. Electrons are released to generate electricity, and the energy produced powers the vehicle. This direct conversion process is highly efficient because it avoids unnecessary chemical transformation and purification stages. As a result, less chemical waste is produced, less energy is lost, and the entire system becomes more sustainable. Another important benefit is that only byproduct produced during fuel cell operation is with water vapor, making hydrogen fuel vehicles much cleaner than gasoline or diesel vehicles. Overall, hydrogen fuel technology demonstrates how green chemistry principle can be applied in real life to create cleaner, safer, and more sustainable transportation for the future. That is all from me. Thank you for listening.
Now on to principle 9, catalysts. So hydrogen fuel cell vehicles rely on catalysts within the fuel cell to enable electrochemical reaction between hydrogen and oxygen. So what these catalysts do is they increase the reaction and amplify the reaction so that more energy is generated. The main catalysts that's involved in this hydrogen fuel cell vehicles are platinum-based catalysts that are commonly used at the electrodes of the fuel cell. So these catalysts speed up the splitting of hydrogen into protons and electrons, and they also accelerate the reaction between hydrogen protons and electrons to form water. This causes the reaction to be faster, and thus the energy generated is also will take a shorter amount of time. Now, also, why are catalysts important actually? It's important because without catalysts, the reactions would occur too slowly for practical vehicle operation. That means that the vehicle won't be able to reach top speeds comparable to vehicles such as gas vehicles and electric vehicles. And also, more energy would be required for the reaction to occur, and thus more energy to generate the energy. And the fuel cell efficiency would decrease. Now, using catalysts also allows hydrogen fuel cell vehicles to produce electricity efficiently and operate at lower temperatures and also reduce overall energy waste. That's clearly showing how it can contribute to the 12 green chemistry principles. As you can see on this slide, this is how the reaction occurs inside the engine of a hydrogen fuel cell vehicle. So, at the anode, hydrogen gas, or H2, comes into contact with the catalyst, and the catalyst splits hydrogen molecules into protons and electrons. And as it goes down, the reaction at the anode occurs, which is when hydrogen H2 is turned into H plus, 2H plus, and 2 electrons. So then the electrons travel through an external circuit, and this movement of electrons generates electrical energy to power the vehicle. And the protons move through the electrolyte membrane toward the cathode. At the cathode, oxygen combines with protons and electrons to form water. So half of O2 plus 2 H plus ions plus 2 electrons will form H2O, which is what we know as water. So the complete full fuel cell reaction thus is 2H2 plus O2, which will turn into 2 H2Os and electrical energy. In conclusion, the platinum catalyst lowers the activation energy of these reactions, allowing them to occur quickly and efficiently at lower temperatures. This improves energy efficiency while producing only water as the main byproduct.
Hi everyone, my name is Wiana Taskia Mukhtara. You can call me Taskia or Kia, and I'm also a SPA student. Now I will explain about the green chemistry principle 10, which is called design for degradation. This principle states that chemical products should be designed to break down into harmless substances after they are used. In other words, after serving their purpose, they shall not remain in the environment and causing a long-term pollution. As shown in this diagram, A chemical product is used and then degrades into harmless substances such as water, carbon dioxide, and mineral salts. These principles helps reduce environmental impacts and supports the development of safer and more sustainable products. Now, I will shortly explain how hydrogen fuel vehicles are a good example of this principle. So, in this vehicle, hydrogen gas is stored in a tank and sent to a fuel cell. Inside the fuel cell, hydrogen reacts with oxygen from the air to generate electricity, which powers the motor. The only byproducts of this reaction are water vapor and heat. Because water is non-toxic and naturally returns to the environment, hydrogen fuel vehicles aligns well with the principle 10 of green chemistry. Okay, now we can take a look of this comparison table. This table compares hydrogen fuel vehicles with gasoline and diesel vehicle. Gasoline and diesel vehicle emit carbon dioxide, nitrogen oxides, and particulate matter. These pollutants remain in the atmosphere and contribute to climate change, air pollution, and respiratory disease. So hydrogen fuel vehicle emit only water vapor and heat, and we can conclude that it is more harmless compared to the gasoline and diesel vehicle because water is harmless and naturally re-enters the water cycle. Therefore, among the three types of vehicle, hydrogen fuel vehicle fully satisfy the green chemistry principle of 10 because their emissions do not persist in the environment.
Now, on to the green chemistry principle of real-time analysis to prevent pollution. So hydrogen fuel cell vehicles use real-time monitoring systems to ensure clean, efficient, and control energy conversion, preventing pollution before it occurs. So how does HFCVs apply this principle? For one, they're equipped with onboard diagnostic sensor systems, which can sense when the hydrogen is not being filtered properly or the reaction is not occurring how it's supposed to. It will continuously monitor fuel cell performance during operation and track the hydrogen purity. And it can also detect abnormal operating conditions, such as when the temperatures are not right, if the pressure of the hydrogen is unstable, or if the voltage of the hydrogen changes. And it will adjust the system performance in real time for optimal efficiency. Next, the hydrogen fuel cell vehicle also has a pollution prevention mechanism. This ensures that the electrochemical reaction proceeds cleanly, that hydrogen and oxygen can react and create electricity and water. This prevents incomplete reactions that could reduce efficiency or increase emissions indirectly. And it also minimizes energy waste, overheating, and system degradation. So, in conclusion, real-time analysis in hydrogen fuel cell vehicles ensures the system remains efficient, stable, emission-free, and it directly supports the pollution prevention as a core principle of green chemistry, thus clearly showing that hydrogen fuel cell vehicles can prevent pollution and be analyzed in real time to do so. Thank you.
Moving on to our principle 12 of green chemistry, which focuses on minimizing the potential of chemical accidents, explosions, and fire. When we look at hydrogen fuel cell vehicles, safety is engineered directly into the system from the ground up to address the unique properties of hydrogen gas. So on this first slide, we can look at the physical safety features built into the vehicle itself. First, we have the high-strength composite storage tanks. Because hydrogen is stored at incredibly high pressures, these tanks aren't just simple metal cylinders. They are typically made from advanced carbon fiber composites capable of withstanding severe impacts and extreme pressures without rupturing. Second, the vehicles feature hydrogen leak detection system. Hydrogen is odorless and colorless, making leaks impossible for humans to detect. These onboard sensors constantly monitor the system and can instantly trigger safety protocols if even a trace of leak is found. Third, we have pressure relief devices. In the rare event of thermal incident or overpressurization, these devices safely vent to hydrogen gas into a controlled manner, preventing a dangerous buildup of pressure. Now, looking at the second slide, we can see how these safety measures function across different pressure zones within the vehicle system architecture, ranging from high pressure storage cylinders down to lower pressure fuel cell itself. To support the system, three additional core components are vital. So first is the ventilation design. Because hydrogen is the lightest element, it rises and disperses incredibly fast. Vehicle and garage ventilation system are designed so that if any hydrogen does escape, it quickly dissipates into air rather than pooling and creating a flammable mixture. Secondly is catalyst and system management. The control system dynamically manages the chemical reactions inside the fuel cell, monitoring temperature, gas flow, and shut-off valves to keep the entire process within a safe operating window. And finally, infrastructure safety. This extends Principle 12 to the refueling stations. Features like automatic cut-off valves, check valves, and robust grounding ensures that transferring hydrogen from a station to the car is just as safe as filling up traditional car at the gas pump. Thus, in conclusion, hydrogen fuel cells support many of the 12 principles of green chemistry because they are cleaner, energy efficient, and produce very little waste. Besides from hydrogen fuel cells, battery electric vehicles or BEVs are also greater alternatives for environmental friendly transportation. Both technologies can help reduce dependence on fossil fuels and support a greener future.